sorry about that. Okay, so mean reversion is you're trying to buy low and sell high right here. Momentum is you're gonna buy high and sell higher. So you might be buy here and then you'd sell here. And so these are like two main strategies, like and these are the two most common strategies within algorithmic trading, like whether people notice or not. And pairs trading is one form of these types of strategies. So say you have like this pair, and this is like, say this is Coca-Cola, right? And say this is Pepsi. And pairs trading is when you want to buy when the difference is abnormally high and sell it when the difference is smaller than usual. So if you just plot the difference here, it'd probably be like this. So it start out high and then goes low and then it just keeps lowering. And then here, let me just fan it out a little bit more. And then it goes like that. Maybe it'll look like something like that. And so you want to buy these. So when the spread is high, you want to long this stock and short this stock. And so like here, so what that does is when the spread tightens, like even like when the spread tightens, you profit. Like it doesn't even, they don't have to like here. They don't even have to like, so here, so the price went down and the price went up. That's like the ideal scenario. But actually, what happens if both of them go up? Like something like this. Okay, so what happens if you buy here? Well, like you long this stock and you short this stock. And even though you lose money on this stock, you more than recover the gains from this stock because it goes from here to here while this goes from here. So you would have lost, here, let me just. So you would have lost this much, but you would have gained far more. So if you compare the lot, like it's not a lot. So pairs trading, what it allows you to do is it allows you to make profit. Like sometimes you can make money even when both stocks go up or both stocks go down. And however, if you notice here, this is not really momentum. Now this is very similar to this mean reversion trading. Because this way, if you buy the pair, if you long this and short this, this would be like your portfolio value. And so pairs trading can artificially introduce an element of mean reversion. However, what you can do now, okay, so this might be a little confusing. So like this pairs trading thing. Oh, shoot. Sorry about that. So what happens if you introduce, oops. Now you can actually introduce multiple stock series. And now, so say this is A, this is B, and this is C. Now you can make some linear combination of A plus like some, so like maybe like, okay, so plus like some beta C, B, and plus some beta C, and beta can be like it could be like any real number. So now maybe we could try to make some linear combination to make a mean reverting. Oh, question. Oh shoot, I can't. Oh shit. Oh, thanks for telling me. Here, let me just restart it. Okay, sorry. I'm so sorry. Actually, okay, so let me just go over it. Okay, so there in trading, there's two main types of trading. So there's mean reversion. So like say that, and so here you want to sell, and here are the points you want to buy, and so that's buy low, sell high, right? So you buy. So say you can buy here, and then you sell here. You buy low, and then you sell high. here you buy low, you sell high. However, momentum is buy high and sell higher. So you'd buy here. Okay, so let's just do mean reversion here. And then this is momentum, momentum. So you buy here and then you sell higher. So these are quite two different. So these are the two of the core types of trading strategies that are like done with algorithmic trading. So like this might like, wait, aren't these like opposite to each other? How can you be profit? Like how can you profit from momentum when, how do you know when to use momentum or mean reversion? Like these two seem to be like opposite here, because like here it goes up and down, so you want to sell early, but here it goes up and then it just keep going up. And this is, so yeah, so they may seem contradictory, but we can we can do stuff. We can analyze the time series to like have a different strategy that trades like this time series, and say this is maybe like say this is like some gold ETF, like gold ETF. And so we can analyze this time series to see the degree of mean reversion, right? And so you can see the degree of mean reversion here, and maybe like let's just say this is Apple. And so this time series has more momentum. So when it goes up, it wants to go up even more. And so the way you decide to do mean reversion or momentum is to analyze the time series with different tools like Hurst. Hurst is one tool that so Hurst is like between 0 and 1. And this is okay, so it's more, so on the left-hand side, the more closer it is to 0, the more mean reverting is, and then the closer it is 1, the more it resembles a momentum time series. So this would be probably like a point. So this might have like an H of like 0.9, H equals 0.9. And this would be like a pretty good Hurst, like pretty low Hurst, like 0.3 maybe. And however, we can actually artificially introduce mean reversion by pairs trading. So pairs trading is going long on one stock. So say this, like say we have this, like, oops. Okay, so so now let's just plot the difference. So it's like, so like it might be like low, and then the difference, so like how this is A and this is A, and then let's just plot A minus B. Well, it'd be negative. Shoot. And then it might look something like this. And if you think, like, the theory behind pairs trading is that when two stocks diverge, like Coca-Cola and Pepsi, when their prices diverge a lot, you expect that to be like something out of the ordinary. But like Coca-Cola and Pepsi, their prices should move pretty closely together, right? But when their spreads diverge, when the spreads diverge, you'd expect them to like come back to each other. So like here, let me just make a flat series. Okay, so here, so maybe it's like this, right? So when the spread becomes this large, you'd expect the spread to like decrease. And so what we can do is long Coca-Cola, maybe like, let's just say this is Coca-Cola and this is Pep. Here, we'd long Coca-Cola and short Pepsi. And here, this is an idealized scenario. The Coca-Cola goes up and the Pepsi goes down. So that'd be the best scenario. But however, so one goes up and one goes down. However, they can actually both go up and we can still profit. So say here, the spread is high here, but the spread is low here. However, let's just take this. Let's just say we shorted A, and then we went long on B. So even though we lost money on A because they both went up and we shorted A, because B went up far more, because gains from going long on B far outweighs loss on A, we get this, we actually profit. And so like here, so like you might be asking, why don't we just go long on A and long on A and B? Why did we have to incur a loss on A? Well, if you think about it, if we like flip this graph upside down, oops. So if you flip this graph upside down, and we go long on one and short on the other, and they both go down, we wouldn't lose, like our losses are capped by the max difference. And so what this does is so by going long on one stock and going short on the other stock, it creates first of all, it creates an element in mean reversion. And second of all, it allows us to profit. There is an opportunity to profit if both go up or both go down. And it also reduces our risk. And it reduces how much money we can lose. So you might be thinking like, well, then why doesn't everyone do pairs trading? Well, not everyone. Well, why isn't pairs trading just like so easy to be profitable off of? Well, that is because your gains might be as much. Although the amount of money that you can lose is decreased, the amount of money you can make is also decreased. And so this is just with two stocks. So can we extend this idea to like multiple stocks? So say we have like multiple stocks. And so look at these. They're not as pretty. Like here, you can tell that they move quite together. However, what happens if we have like some A, B, C? So what we can do is we can buy like some A and then some beta B, then beta 1B, and then some beta 2C. And then we can try to create a portfolio that looks more like a mean reverting portfolio. So we can buy here, oops. So we can buy here and sell here. And so what we can do is do some math to find the best beta coefficients. Like here, let me just, wait, maybe I didn't explain beta. Here, let me just explain beta. Okay, so say we have like so beta. Okay, so this is B. And then so here, let's just do, this is beta B. And so this beta here would approximately be 1/2. And so why do we want to do this beta stuff? Well, here, let me just draw it out. So now we can scale C up to some beta C and get it up here. And we can scale down A using some beta A and move it down here. And so that so what this allows is that like price series with much larger prices just don't like cancel out whatever happens. Because like, let's think about it. So let's just say we have like something here, and this is like 100 scales. These are in like the hundreds. And then we have something like, this is like 2 cents, right? And if we did the difference, then it'd be just the hundredth, right? Because the 2 cents would barely impact it, right? But now let's think about it. What happens if this was now in the 50s? Now this would be, now if we subtract these two time series, it'd be in the 50s. And now let's do 100. Let's make this time series 100 and move it all the way up here. When we subtract the two time series, it'll oscillate around 100. And the second time series, by scaling it up, it will have an effect on this time series. So that is why we have these beta coefficients to scale the stuff. Okay, so how can we determine these beta coefficients? We can do something called OLS. Okay, so this is another concept. And this is from statistics. Okay. Oops. Okay, so let's just have a graph of like degrees Celsius, oops, there, degrees Celsius and ice cream, ice cream sales. You'd probably notice some like positive correlation, right? And then you could draw some like line of best fit. And then you can plot the errors. Like here. Like this line isn't gonna be perfect, right? So like we just have a bunch of these points, right? It's not gonna be perfect, so we're always gonna have some like error. And if you plot these errors, it'd probably like be around 0. It'd be like randomly or scattered around 0. And that's OLS. You notice something? What happens if we, so let's make an assumption that this is like a homoscedastic. We hope it's homoscedastic. We can do like homoscedasticity is let me increase my brush size. Homoscedasticity is like this. But what is non-homoscedasticity? Like this. This would be heteroscedasticity. And you can see it fans out, right? We want something like this. We want this. Like the error, like the average error doesn't really just increase too much. We just want it like that. And when we have, so we want that, right? And when we have a scatter plot like this, we can notice that the errors stay around some area. So what happens if we plotted two price series against each other? Let's just do this. Okay, so pip install Yahoo Fin. I also need so I'm just so Yahoo Fin from Yahoo Fin imports stock info as SI, and SI will allow us to pull some stock data. So let's just get some data. So data equals SI dot get data APL. Let's do 01 2015, and then let's do 01 2020. Okay, so excuse me. Let's just look at this data. And so we can get the open, high, low, close. Okay, so let's get the, so KO equals KO, and let's get Pepsi, KO. pep. Just copy the dates over. Okay. Now let's plot them against each other. Import matplotlib.pyplot as plt. plt.plot ko. We want the close against the close of pep. Scatter. Oops, I want to scatter. Isn't that quite interesting? Well, it's a little more fatter than I expect. Okay, so usually you probably, that's actually quite fat. Like I'd expect it to be a straight line. Like these days, there's all these like HFT bots, like HFT algorithms. Like when the price deviates, then the HFT algorithms all like rush in to freaking buy the spread, and it kills the spread. But there's actually quite a bit of, it's quite interesting. But you can see here that there's a positive linear correlation. And so let's now add a line to it. So numpy.ols. So let's just pi OLS. So res equals, here, let's just see what it will look like. MP. Yeah, let's just make this both close so it's easier. Okay, so numpy.ols pepco. Oops, I didn't import it. Actually, let's just use stats models OLS. It's OLS. Okay. Pepco. Shoot, I forgot. Res dot weights. Oh, it's dot params. Okay. Oh, I need. Yeah, it's kind of weird. Okay, now. Okay, so that's like the slope here. Yeah, let's just use stats model layer. Okay, so import numpy as np np.ols. I can't remember how to do it. NumPy. Oh, I swear I did it earlier. Shoot, sorry. I can't. I don't know why I forgot. Oh, it's called polyfish. Sorry. XY degree 1. Oops. Okay, now it should be. Now, okay, now we have it. Okay. Okay, so let's just like create. Okay, so just copy that. And let's just put that line on there. PLT dot So our x will be like I for I in range, let's just do like 35 to like 60. And then times. Okay, so the first is the res equals, okay, so res 1 plus res 0. Okay. Oh shit. Okay. Run, don't say it. I'm doing something. Okay, shoot. Oh, I think you caught that. Mm-hmm. Why is it so big? Sorry, never mind, I'll just figure it out later. Okay, so just imagine that there's a line through there. What the heck? Oh, I think I'm doing. Oh, I put it in the argument wrong. What is? Oh, whatever. Shit. Wait, just imagine that there's. Okay, whatever. I don't know what's going on. Okay, so now let's just think through this is PEP and this is CO. And you guys saw that it looked like this. And so if we put a line through there, we get some like coefficient here. The heck? Why is that working? Maybe I'll Oh. Okay, there we go. Holy sh. Sorry about that, dude. The API. Okay, so yeah. Okay, there we go. There's the line. And so what we can do. Okay, so let's just copy this. Okay. Sorry about that. Oops. Okay, so let's just. Okay, so you can see. Okay, so you can see that there's some errors here, like, and every point is like time, like one time, at one time step. And so we can here, and then let's just plot these like red bars, errors, right? Let's just do that real quick. And so we have this resid.params. So let's just plot the residuals. Field plot res.resid. It is resid. Why isn't it showing on? And then you can see that here. Let's just look at this. So we're just plotting the difference between. We're just plotting the difference between Pepsi and Coca-Cola. After we have like some red zero. Okay, so here, let's just plot this. So PD, here's a cool trick. So import pandas as PD. You can put it in the data frame. So PD.data frame. Let's make a new cell actually. Okay, PD.data frame. So KO for KO, and then PEP for PEP. Let's just plot this. Okay, so you notice that like, so let's just now multiply this KO by some like by this res earlier. So res 0. Oh wait, I need to rerun this because I overwrote my old res. And now you can see that the series are much closer together. So that's the power of having that beta coefficients. Like that allows us to scale up the time series. Yeah. And so now we take, so once we scale up the time series, and let's just, there's one. And now you can, okay, so adding in that final thing, now you can see that the time series like intersect a lot. And so we can, oops. And so now, so I've applied the OLS equation to the Coca-Cola to scale it up to being close to Pepsi. And once, so let's just here, and if we plot the differences, you can see here that they both go up, right? They both, there's a consistent uptrend. Oops. There's a consistent uptrend, right? However, once we apply the OLS and get the errors, like make one a multiple of another plus some like constant, now it's mean reverting. And so what we can do is we can buy at these points and like sell at these points, right? And the portfolio would be some like KO. So what does this portfolio look like? It looked like PEP minus the beta for KO, right? And so what is this beta here? It was res 0, and let's just res 0. It's 2 point, so it'd be like something like 2.8 times Coca-Cola. And so when the difference, so when we plot out PEP minus 2.8 Coca-Cola, here we'd want to buy Pepsi and sell 2.8 units of Coca-Cola here. But then when we get up here, we would want to reverse this portfolio. So we're going long here, long, short. When it goes up here, the portfolio goes up here. We want to reverse our portfolio and sell it. So we do negative PEP plus 2.8 KO. Hopefully that makes sense. Okay. Okay, so what does this look? And what we can do is we don't have to limit to just Pepsi and Coca-Cola. We can do Pepsi, Coca-Cola, Publix, Snapple, Dr. Pepper. There's all these. So what we can do is we can apply the OLS and find the error terms for multiple things. We can add like a bunch of these. And then we can do all that. And by adding more, we can optimize these weights to give us a better mean reverting. So this isn't perfect. You can see here, like it doesn't go all the way down. But once we add more stuff, we might be able to get better mean reversion, something that looks like this. Okay, so what does this look like? And how do we make this into a code? Okay, so oh yeah, and so how do we test how good this thing like goes back to me? We use something called stationary test. Like this would fail the stationary test because it goes. Shoot, there's so many concepts. Maybe I should like make like okay. Maybe I should like just make. I need to make a list of all the concepts people need to know. Okay, stationarity is where the mean and the variance stays constant over time. So you can see here the mean here, the mean here, and the mean here stays relatively the same, and the variance stays relatively the same. And so this thing is stationary. So what are some non-stationary series? So you can see here the mean here, then we have the mean here, then we have the mean here. So you can see that the mean is constantly increasing. How this? So that is not stationary. So let's add another one. And you can see here that the variance is constantly increasing. Like the spread between the mean, like you can see here, the variance is increasing. The variability of the data increases. So they're not stationary. So we want a time series to look like this. So how can we test for this? There's some multiple tests. We can use Dickey-Fuller, augmented Dickey-Fuller, and then Phillips-Perron. And so these are just two stationarity tests. There's a lot of stationary tests. And there's a bunch of ones. Johansson's. There's okay, it's not there. Okay, so there's Johansson, Dickey-Fuller, augmented Dickey-Fuller, Phillips-Perron. There's a bunch of different ones. And so here, okay, so let's go into the algorithm. So here I just have a function, so you can just pass in some data, and it just checks if it passed the significance. So like if the significance is if the p-value is too high, the probability that it is, the probability that we reject, okay, okay, so we have a hypothesis testing. And so here, we can't reject the hypothesis. Okay, so this is like just, okay, so think about it in statistics. When you have like hypothesis testing, you want to have like 5% significance. Hopefully, I hope, I'm not going to explain that now. Hopefully you guys already know this. Like in high school chemistry, you like test for significance levels, like 5% significance. And if your p-value is like below your accepted significance, you can reject the null hypothesis and you can accept your hypothesis-ish. So here, if we can't get, if our p-value is too high, we can't reject the null hypothesis. So it is not. We have to say that it is not stationary. Here, the same thing. But if we manage to pass both of these tests, then we can say it is stationary. Here, I just apply OLS. I check that the residuals are stationary. And if you remember from earlier, the differences between these two time series are the residuals. And we want the differences to be stationary because that means we can train it as a mean reverting portfolio. Okay, so you can see here like the differences, like they don't really vary too much. Like they keep coming back, like they keep intersecting. What happens if we had two times? What happens if we had one time series that look like this, and then one time series that look like this? And if we plot the differences, it's like starts out small, and then it just keeps increasing. However, we want these differences to look like this, so that we can buy here, buy the portfolio and sell the portfolio here, right? But here, like here maybe it converges. Like it might even not even be perfect. So we can't even treat it as a momentum problem. We can't even. So that's why we need to check for the residuals or the differences between these two things are stationary. And then, okay. And so we can create a portfolio using the weights, as I said earlier. So here our portfolio would be going long some Pepsi and some shorting some like multiple, some like 2.8. So 2.8 plus some like constant. So we go long on Pepsi and go short on Coca-Cola or something like that, or go short on Coca-Cola, go long on Pepsi based on where our portfolio is. Like if it is here, we go long on portfolio, short on portfolio. Okay, oh, that makes sense. And so what we can do is, okay, so something we do here is we actually regress one time series against the other 3 time series. So we have BTC, ETH, BCH, and LTC. What we do is we make BTC some linear combination of ETH, BCH, and LTC. So that means BTH equals beta, alpha. So our equation would be, I actually have it right here. So the price of BTC, where you regress against the price of BCH, ETH, and LTC. And these are just cryptocurrencies, just like, and so we make this, and then our portfolio, if we go long on BTC, then we want to go short on all of these things. We go negative beta on all of these things. I explain it here. So if we go long BTC, we take a position of, okay. So this is just like not very, like this isn't very important. I just like, this is just all to set up, like adding like the data, keeping track of the data. Okay, let me just go over this line by line. Okay, so this is pretty trivial. Set start date, set the start date of the algorithm backtest, cash, how much cash you start with, blah, 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 blah. Okay, blah, 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 blah. Okay, so this will keep track of historical data, and we can convert this thing into a pandas data frame. And we retrain the coefficients. The reason we retrain the beta coefficients, we retrain these beta coefficients periodically because the dynamics of the relationship might change over the time. Like the beta might change. So that's why we need to constantly retrain it. I just retrain it every week just so it's frequent enough so that we can capture the changes in the price dynamics. Okay, so I make a portfolio and a portfolio just keeps track. And so how do I determine the buy sell signal? So say this is the portfolio of BTC minus some beta BCH, beta 1 minus beta 2 ETH, blah, 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 blah. And so what I do is I take the mean, then I take the standard deviation, which is a measure of variance, and I do like 1.5. So the mean time multiplied by the standard deviation plus 1.5, and mean minus the standard deviation. So this is mean. So mean plus 1.5 sigma, mean minus 1.5 sigma. You can experience with different like thing you put in the front of the sigma, like 1, 1.5, 2. It doesn't really matter, but we just chose 1.5 because that's what the paper said was the best. And then our rules is, so the paper just buys here, right? Let me just delete everything. So the paper, so say this is the graph of our portfolio, and we don't have to enter the portfolio immediately. And so the paper buys it here. The paper would buy it here when it passes this lower level. It buys it here. However, I changed it up a little bit so that it watches here. So it watches. So we start watching this. So I start watching it here, and then blah, 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 blah. And then when it goes here, then I buy. And so what this allows us to do is reduce the amount of drawdown of portfolio, because if we buy here, then this is our drawdown. But if we buy here, we don't really have much drawdown. Okay, so here, this is what I was talking about. The standard deviation factor is 1.5. So upper, lower. So like if it trips the upper, here, let's just like, if it trips lower, we, if the spread is like the value of the portfolio. And it's called spread because it's a spread between BTC and the other three cryptos. And so when the spread trips the lower bound, we start watching it, self.tripped lower. And if we trip lower and the spread goes back up above the lower bound, so we can see it goes back up to the lower bound, we return 1, which is a buy signal. And we do the opposite for the upper bound. And so that's basically the triggers. Hopefully that makes sense. Let me just post the algorithm. Does that make sense? Do you want me to like go over anything? Like any statistical? There's so much statistics. I went over deep learning and machine learning, but I didn't even go over OLS, the basics of statistics. Okay. Hopefully that all makes sense. Like this is not like. Okay, yeah, that's about it. I'm just gonna stick around if anyone has any questions. Oh yeah, let me show you what the graph looks like. Here, let's just back this to. I make some pretty cool graphs. It'll help us illustrate what it looks like. Okay, so you can see here. So the middle line, the thing in the middle, is the value of the theoretical value of the portfolio if we held it, and this thing at the top is the upper bound. This is the lower bound. See, when we trip it, we buy here. You can see here the red. So there's red diamonds acts. What did I get it red on there? I didn't have a runtime earlier. Oh, that's probably just some like error. Okay, so you can see here that like, look, isn't that cool? So we buy here, we sell here, we short here, we go long here, we go short here, we go long here, we go short here. And you can see that like it keeps crossing over these 1.5 times the standard deviation plus or minus the mean. no, mean plus or minus 1.5 times the standard deviation. It crosses over quite a bit. And you see this strategy is quite interesting. It works. It's a little bit profitable. Sharp, it does okay, I guess. And the problem is that we don't really have enough, like BCH only came out like 2017, so we don't really have a lot of data for BCH. Okay, and you can see here, like, okay. I'll also post this in the chat if you wanted to read it. I'm also gonna post this in the video. What the heck? It losing money. Oh. That's weird. The sharp actually increased. Yeah, let's end. Excuse me, do you have any questions? If you don't, I'm just gonna like end the record. I'm just gonna end the meeting in like 5 minutes. Oh yeah, it's the second link. It's just here. I'll post it again. Maybe you can read it over and ask me any questions so I can stay around. Oh yeah, happy Veterans Day. It's really nice. Oh yeah, sure. I forgot to talk about the Quantitative Analytics Lab. Okay, for anyone who's still watching, if you're interested in the Quantitative Analytics Lab, go to our Facebook, ATC. Oh shoot. Okay, so go. Okay. That's wrong. Are you kidding me? Okay, just type in ATC dub. I cannot. Where is my club? Our Facebook page doesn't actually work. Are you kidding me? Please do that. Where? No. Okay, whatever. Here, let me see if I can find Facebook. There it is. Okay, so anyone who's interested in working on projects through Quantitative Analytics Lab, go to one of our social medias. This is wrong page. Yeah, our Facebook page isn't open. Like this group there. Don't go to our Facebook page. I don't know who. Like our Facebook page is dead. Use our Facebook group. Go to one of our social medias. This is for those who are interested in work in QL and would like to work on the quant project. So this is very similar to what we did today. It's actually the same thing, actually. It's actually the same thing. This is with the CF arm. The Quantitative Analytics Lab is with the CF arm. I'm also going to post this in the video. I'm also going to post this in the channel, in the description. If you're interested in working on applying like your skills to like a tangible quant project, definitely check out this Quantitative Analytics Lab mean reversion trading project. Oh, one second. Okay, definitely check out the Quantitative Analytics mean reversion project. It's being hosted by me and our club advisor, who's also the head of the CFRM department. If you have any questions, just feel free to reach out to me. I can help you with anything Quant Connect related or tech, like about the math. Yeah, I think it's really nice because getting hands-on experience is it's something good that you can put on your resume. But it's also like it'll also allow you to get to experience with applying this stuff. I hope everyone here, did I post in the chat? Here, let me post in the chat. Okay.